The 1954 Commonwealth Games were held in Canada. The marathon winner was Joseph McGinn, but an Englishman had reached the stadium 10 minutes earlier.
The crowd is shocked into silence as Jim Peters enters the stadium. Almost stunned, and with his effort, he stumbles towards the finish, groping, blackened, bewildered figure. If anyone should help him, he would have to be disqualified instantly.
Jim Peters got to within 65 metres of the line, but he never finished the race. The heat was too much for him. Keeping cool is... You have to understand about keeping cool if you take running seriously. How do animals keep cool in hot countries? It's easy for them if there's enough water to wallow about in. Why do you think they might be cooled by water or by mud? And what can they do if there's no water or mud? Elephant is for keeping cool. Early in the morning, an elephant is comfortable and warm, but when the tropical sun comes up, the elephant's in danger of overheating. So it has to get the heat out of its body into the air outside. The elephant does to get rid of the extra heat. Inside, warm blood carries heat to the skin. The heat goes away and cool blood flows back to keep the elephant cool and contented. Why do you think the elephant's ears are so big? Can you guess why this five-toed jerboa has such big ears? And what about rabbits? They have naked skin inside their ears, and the thermo camera shows this is warmer than the fur. Do you think the rabbit uses its ears to keep cool? How do people avoid overheating? Suppose you took violent exercise. What would you expect to happen to your temperature? The longer you go on running, the hotter you feel. Does this mean your temperature is going up? There are two places you can measure temperature easily, the mouth and the skin. The skin temperature is just over 32 Celsius. The mouth temperature is nearly 37. What would you expect to happen to these temperatures after a few more circuits? There's a clue here. What do you notice about the colour of their faces? Why do they go so red? Remember the overheating elephant? The blood cooled it down by carrying heat out to the skin. You work the same way. When you start overheating, extra blood flows to your skin. That's why you go red in the face and feel hot. What would you expect to happen to your skin temperature? The skin temperature has gone up to 35 Celsius, but the mouth temperature has hardly changed. At the start of the experiment, the average mouth temperature was about 36.5 Celsius. After several circuits, it went up about half a degree. The skin temperature started lower, 32.5 Celsius, and went up more than 4 degrees to reach 36.5, almost as high as the temperature in the mouth. Elephants have big ears to cool themselves. Big ears surface area, so they can get rid of lots of heat. What do you think the elephant would do if its ears were to shrink? And why do you think that animals with very small ears, like hippos, spend so much time in the mud? People don't have big ears like elephants. What does your body do to keep you cool? One thing you do is sweat. Can you think why sweating might help to cool you down? Most other animals don't sweat. What do dogs do to cool themselves? How do you think panting keeping cool? Think about this while you do it. If you hold your hand close in front of your mouth and breathe out gently, it feels warm. But hold your hand 10 centimetres away and blow. How does it feel now? Can you explain the difference? And how does it feel if you stick out your tongue and suck the air in over it? Does it feel cold because your tongue is wet? When you go swimming, you often feel colder after you get out than when you're in the water. Can you guess why? It must be because you're wet, that the water takes heat away as it dries. Is it the evaporation of the water that cools your skin? If you take 2 thermometers, wrap paper towel round the bulbs and wet one of them, you can try it out. For a fair test, blow air at both of them. To begin with, both thermometers show a temperature of 22 Celsius. Will the fan cool them both down the same amount? No. The dry paper towel still shows a temperature of 22.7, but the wet paper towel is drying in the wind. As the water evaporates, it takes heat away. The temperature's dropping, 20.5, 20.4, 20.3, and still going down. So wet things do cool down as the water evaporates. Would this keep your milk cool if you didn't have a fridge? People claim that they can cool water by keeping it in an unglazed pot. Let's test the claim by putting hot water in this pot, which is glazed only on the right-hand side. Soon, the warm water soaks through the unglazed side and makes the outside wet. You can see the water coming off the outside, but not where the pot is glazed. Unglazed pots are sometimes called chatties. How do you think a chatty could cool the water down? This unglazed pot is a wine. Can you work out how it might cool a bottle of wine? If your horse knocks its leg, you can tell where the injury is. It feels swollen and hot. One thing you can do to cool it down is make a poultice. Some people believe in the special effects of a poultice made by mixing china clay with cow pats. China clay into the cow pat to make a sticky poultice. Then apply it to the injured leg. The idea of the poultice is to draw out the heat as it dries. Why do you think it might work? When you make a pot of tea, it's usually too hot to drink. How do you cool it down if you're in a hurry? Some people tip it into the saucer. Shows that this is a good idea, scientifically at least. The tea in the cup stays yellow, which means hot, but in the saucer it quickly cools down. Can you work out why? How many other ways can you think of to cool a cup of tea as quickly as possible? What's the quickest way to cool a cup of tea? Remember that water cools things down as it evaporates, and that a big surface area helps. In this competition, each group can choose any one piece of apparatus. Then they have 5 minutes to see how much they can cool the tea.
Everybody ready? Okay, start now.
Oh God, I can't get sponge in. Go. Get the water and soak it into the sponge, and once you take it out, it changes temperature. When you put it back, it's colder.
They're using the same idea as the unglazed pot. The next pair have put their tea in a tin mug in a cold water bath.
The coldness of the water is going to, the metal is going to conduct the coldness and cool down the heat in the cup.
We're going to use this fan so the air coming past will get blown into the tea and it'll cool it down.
Well, if you blow cold air into the tea and it also bubble it can get all the heat, the hot air out and also cool the liquid itself.
I'm going to use a tin tray. It's a conductor, so all the heat from the tea will go to the cold tray, and we're going to...
Going up, it's still going up. 49.
49.
Ours is 35 degrees. Ours is 45 degrees.
45.
Yeah.
We got 45.
But the outright winners were the pair with the tin tray. By using a big surface area and blowing as well, they cooled their tea right down to 21 Celsius. Very hot, and they have to get rid of the extra heat to the air. Why do you think they're made with fins that have a large surface area? To stay cold inside, a fridge has heat to the air at the back. Behind, there are fins with a large surface area. Car radiators work in the same way. There's a huge surface area to get rid of the heat from the engine. How does the heat get from the engine to the radiator? The engine runs inside the cylinder block. Heat goes into the water, which flows round the outside. The water carries heat out of the engine, just as blood carries heat out of the elephant. One thing that produces even more heat than a car is a power station. To run its giant turbines, this power station burns coal dust in huge boilers. There's an enormous amount of extra heat to get rid of. How does a power station get rid of heat? Remember the elephant's ears? The ears of a power station are its cooling towers. Keeping cool is so important that the cooling towers are 100 meters high, much bigger than the power station. Look at the inside. Across the middle of the cooling tower runs a river of hot water. Otherwise, it's a gigantic chimney, except for the fog. The hot water runs down and out through thousands of sprinklers. Some of the water evaporates, and this cools the rest of the water down. Up above, thick swirl fog. This isn't smoke, it's only water. Down below, the cooled water runs back to be used again. It's still warm though, and at some power stations they use it for fish farming and growing tomatoes. So, if you were organising a marathon, what advice would you give the runners? What sort of clothes would be best for keeping cool? What time of day would be best for the start? And what precautions would you take at the finish?